Okay, welcome to my last video on optimization here, and again feel free to subscribe if you like what you see here. So we're going to talk about, we're still talking about applications of derivatives and optimization, and I told a small fib on the last video. I said that this was going to be trig. It's actually not trig, but it is geometry. So but you don't have to do any trig in this particular problem. Okay, now it might be able to be done using trig, but I didn't use trig in here. I just used geometry and algebra. So first of all, we got two posts. Here's one post right here. Okay, so that's a post there. If I can get it to line up. Anyway, you see that's a post there. And then there's another post over here. Okay, so there's a post there. Alright, so you have those two posts. And this post is 12 feet high, and this post over here is 28 feet high. And they're 30 feet apart, so the distance from here to here is 30 feet. Okay, and we're attaching two wires, so I'm running a wire from this top of this post to the ground, and I'm running a wire from the top of this post to the ground, and they're attached here to some stake. So the question is, where should I put that stake in order to minimize the length of wire we're going to use? Okay, so here's what we're going to do. All right, our primary equation is going to be y plus z. Y plus z. So I'm going to let w equal y plus z. Now, I already see a typo here, so I'll fix that in just a minute. But w is going to be y plus z, so let's fix this right here. So w there should be equal to y plus z. All right, now, if you look at the triangle here on the left side, this triangle, small triangle, right triangle, then you know that basically what I'm going to do here is I'm going to call this length here x. So this is going to be x, and since the total distance between the two posts is 30, then the distance, this distance right here is going to be 30 minus x. So basically this is going to be x right here, and then this is going to be 30 minus x. Alright, so now since I've called this x and I know this is 12, then I know, using the Pythagorean theorem, I know that x squared plus 12 squared must equal y squared. So that gives me this equation. Now over here on this side, I know that 30 minus x quantity squared plus 28 squared has to equal z squared. Okay, so that's my right side equation. Now, if I simplify the left side equation, I get x squared plus 144 equals y squared. If I simplify the right side equation, I actually get, let's see, if I square this, I get, what is it, 900 minus 60z plus x squared, and then I add it to 28 squared. And so you can do the arithmetic there, but that's just going to give me, x squared minus 60x plus 1684 equals z squared. Okay, now, the reason I wanted to get y squared and z squared is because I know if I have y squared, I can get y, and if I have z squared, I can get z, and my primary equation involves y and z. So now, take the square root of y, the square root of this, and that'll give me y. So the square root of y squared is y, so the square root of x squared plus 144 must be y, and then the square root of this trinomial must be z. So now I have, here's y, here's z, and that represents the equation that I'm trying to optimize. Okay, so now let's write these as with rational exponents. So the square root of x squared plus 144 is x squared plus 144 to the 1/2, and the square root of this trinomial would just be this trinomial to the 1/2. Now, I'll let you take the derivative of this, but just apply the power rule to this and the power rule to this, And once you simplify it, you'll get x over x squared plus 144 to the 1/2 power plus x minus 30 over x squared minus 60x plus 1684 to the 1/2 power. Now, we want to set that equal to 0 because that's the derivative. So we set the derivative equal to 0, and I can do that. To solve that, what I can do is I can move the negative term to the, I move the term to the other side and it changes sign. So basically, let me get rid of this and I'll show you what I did. I basically took this term and moved it to the other side, and it made it a minus. So when I minused it, it turned the x minus 30 into 30 minus x. Okay, now I'm going to just cross multiply. Remember, you can cross multiply because this is a proportion. So multiply x times this, and then multiply these two together, and you get what I've got here. Okay, now this is some nasty algebra here, but square both sides and perform the algebra. So if you square both sides and then perform the algebra, basically squaring both sides will get rid of the exponents, and then you'll get x squared times x squared minus 60x plus 1684, and then over here you'll get 900 minus 60x plus x squared times x squared plus 144. Now we're going to distribute, let me show you here, we're going to distribute this x squared through, and then that'll give us x to the 4th minus 60x cubed plus 1684x squared. And then on the other side, I'm going to multiply those two polynomials together, and you can do that on scratch paper, but basically I get a bunch of terms. So you can check that on your own, but multiply these together and I get these 5 terms here. Okay, now the x to the 4th will cancel, and the minus 60x cubed minus 60x cubed will cancel. And so let's see what that's going to leave me with. X to the 4ths are canceled. The minus 60x cubes will cancel. And now let's see, I get 1684x squared over here, and if I subtract, that would give me minus 600. That would give me 640x squared if I subtract this from this. So that gives me 640x squared. And so that takes care of these guys. And then just move these two guys across the equal sign and you get that. You get these two terms. Okay, let's see. That's going to be plus, and let's see. I think I may have a typo here. That should be minus if that's a plus. Okay, so anyway, and then you can solve this using the quadratic formula, and you get x equals 9 feet. Okay, I was just double checking this to make sure that I had this sign right. That came from 900 times 144, so that definitely would be a positive, and then when you move it across the sign it becomes minus here, so that should be a minus. Okay, but anyway, use the quadratic formula with A equals 640, B equals 8640, and C equals 129,600, and then you can solve that for 9. If the answer is 9, I'm sure that would factor, but it might be kind of hard to factor since the numbers are so large. But x should be 9. So now go back to the problem. So now we know that we should place this 9 feet from the smaller pole, and which would put us 21 feet from the larger pole, and then that would minimize the sum of these two wires. Okay, and so that's the last optimization problem that I have. Now on the next video we're going to look at Newton's method. I've already worked that problem, so let me scroll past it. So in the next video we're going to talk about Newton's method. So if you need to learn about Newton's method, then be sure and see the next video.